Okay, here's another problem from 6.5, and it's about the salinity of the ocean that changes with the latitude and the depth. Suppose the salinity to the depths of 1,000 meters at a certain latitude is modeled by the function that is given here below. The input x is the depth in meters and the output in grams is the salinity seawater. I kind of cut that off. Approximate analytically the depth where the salinity equals to 36. So this number here, 36, is the salinity which represents f of x. So let's replace f of x with 36 equals 33.7 plus 1.3 log x plus 1, and now it becomes an equation. You're solving for x. The first step is we need to isolate the log x plus 1. So just like you regularly excuse me, would solve an equation, you have to first of all subtract 33.7 from both sides. So use your calculator. 36 minus 33.7 is 2.3. So 2.3 equals 1.3 log x plus 1. Now, to get log by itself, divide by 1.3 and keep as many decimals as you can. So I'm just gonna write down 1.769, but what I'm doing is I'm using the entire decimal number that I see in my calculator, equals log of x plus 1. So we have the log isolated, and to solve for x, we now need to change to an exponential equation. So we need to have a base, we need to have an exponent, and we need to have an output. Now, when you don't see this little number here, right, like so, that means it's automatically understood that the base is 10. So we're gonna get our base of 10, and I call it the circle method. We go over to the other side, that's your exponent. 1.769, and that is equal to x plus 1. So 10 raised to the 1.769, 10 raised to the 1.76920 is equal to approximately 58. Let me just write 78. 58.78 equals x plus 1. Now to get x by itself, you subtract 1, and x is equal to 57.78, and the instructions say to round to the nearest meter, so the depth is approximately 58 meters. So you need to solve the log equation here.